A while ago I bought a new car. Driving is great, but the charging situation could be better. To recharge my car I use this wall box. I basically just have to open this front door, plug in the cable, and the car begins charging. The problem with this is that neither the car nor the wall box give me any control over the charging process. So I know how long it will take and when it's finished, but I can't speed it up or slow it down. The reason why I want to have more control over charging the car is because I have solar panels on the roof and I'd like to limit it to only use that power instead of drawing additional electricity from the grid. Luckily, almost every wall box has some way of controlling it. In this case, it's an internal Modbus header, which gives me access to basically all charging options. As you can see, I already connected a cable to it and this little USB dongle to do some testing with my laptop. So after a lot of trial and error, I finally got a proof of concept working on the ESP32. I'm basically polling the charging status every 100 milliseconds. So when I plug in the car to the wall box, it switches over. Okay, exactly, so now it's on 67, which is the ASCII character for, I don't know, probably C for charging. So now it's running, car is charging up. Now if I stop the charge, it goes back to 66, which is B for plugged in. And now if I pull out the charger, it goes back to 65, which is A for, I don't know, probably idle, which doesn't make any sense, but I didn't make the specs. Okay, so now that the wall box and the ESP32 can communicate with each other, I need to tie them into the API offered by my solar panel controller so I can actually steer the charging. In addition to that, I also need some sort of user interface to see what's going on while charging my car. I already did some experimenting yesterday and I came up with this. It's basically 3 OLED displays connected to a single ESP32. One of them will display the current power generated by the solar panels. One will display the power offered to the car. And one will display the general charging status. Is it running? Is it paused? Is a car even connected? In addition to that, I will add some toggle switch or something to override those smart settings in case I want to charge my car quickly. Okay, so now that the software is all done, I can talk you through how it works. Let's start with the limitations I had to deal with. The first thing is that the wall box only allows for charging between 6 and 16 amps, and also only lets me step up or down the current in 1 amp steps. On a 400 volt 3-phase system like this, 1 amp makes a difference of about 700 watts. In addition to that, I also don't know how much power the wall box and therefore the car is actually drawing, because the wall box doesn't have a power meter and the car doesn't give me access to hers. Luckily, I know how much power my whole home is drawing, so I can control charging based on that. Not really a limitation, but rather a quirk of the wall box, is that I can only set the amp limit when a car is actually plugged in, because the box clears that setting whenever the car gets unplugged. So there's always a small power spike when I plug in the car. Now that you know most important limitations I had to work with, let me talk you through how it's implemented. Of course, everything starts with initializing Wi-Fi, the displays and the Modbus communication with the wall box. For those of you that don't know, Modbus is one of many de facto standards for connecting industrial devices. In this instance, it uses RS485 serial as a transport layer. Luckily, the installation manual of the wall box lists all necessary information I need to connect it and send requests. Since it can't be found anywhere on the internet, I'll put a link to a scan I made into the description in case somebody wants to take a look at it. After all the initialization is done, it goes into the main loop where it checks if a car is plugged in or not, what the current amp limit is, and how much power currently is generated and consumed in my home. This data then gets displayed on the OLED screens. When the amount of consumed power is more than 700 watts lower than the amount of generated power, it increases the charging limit by 1 amp. If the consumed power is higher than the amount of generated power, it decreases the charging amps. It also checks the state of the switch to enable or disable the manual override. With the override enabled, it basically ignores any limit set by my software and sets the wallbox to its maximum. This is done on repeat until I turn off the power or it loses the Wi-Fi signal. For simplicity, it also tries to set the amp limit when there's no car plugged in. But as I said before, the wallbox just ignores that. Requesting the charging state is only done so I can display it on the screen. Now, the next thing on my to-do list is the hardware. I need to design and 3D print a shell to put all the electronics into. I also need to solder everything together because putting a breadboard into a plastic shell mounted to a wall sounds like a bad time. And with the power of movie magic, I already created the case. It has 3 rectangular holes for the displays and a switch to toggle the override. There's also a grommet at the bottom to feed the cables through. So now I have to solder everything onto a PCB and jam it into that box, so I can finally try it out properly. The first thing I did was to make sure the standoffs in the plastic shell actually fit together with the perf board I wanted to use. After that, I had to test fit the ESP32 in place to make sure the pins at the bottom don't clash with the plastic border of the shell. After I made sure everything fits, I soldered it down on the 4 pins on the edges. Now it's time for the Modbus transceiver board, featuring a MAX 485 chip as a middleman between the wallbox and the ESP32. Since the module I got from eBay was kinda crappy, I had to use my desoldering gun to remove the slightly angled pin headers so I could solder them back on straight. Otherwise the module wouldn't have been able to fit. The next component I soldered down was a screw terminal for the 12 volt power input. I also needed a board to convert the 12 volts to 5 volts for the ESP and the transceiver. For space reasons I decided not to solder the 12 volt to 5 volt converter directly onto the board. Instead I opted to connect it using wires and tape it in place later. I then wasted a lot of time figuring out how to mount the connectors I needed for the display and some LEDs, and decided to slightly change the location of the screw terminal. After that, I could place the pin header for the displays behind it. The next thing I did was to solder wires to the DC to DC converter so I could hook it up to the main PCB. I then used my multimeter to set the correct output voltage on the PCB by rotating the potentiometer with a little screwdriver. Yeah, that took a while until I got it right. After I got it tuned in, I soldered the 5 volt cable to the PCB and started connecting the ESP32 and the transceiver board to it. I then started wiring up the signal cables for the pin headers. That also took a while. After that was finally done, I placed the OLED displays into the little holes and screwed on the brackets that holds them in place. Using 6 screws for that was probably overkill, but I wanted it to look nice. Then I did a test fit for the box that would hold an LED strip later. That strip will light up the lettering from the back. Since the box did fit like a glove, I continued the assembly by soldering power wires to the cold white LED strips I selected. I then fed the wires through the small hole on the side of the box and finished screwing it on. To see how it looks like, I hooked up the wires to my bench power supply and gave it 5 volts. It doesn't come across that well on camera, but it looks pretty good in person. Now that the front assembly was finished, I could create the wiring harness that would connect it to the PCB. It looks pretty messy, because, well, it is. But if you look at the wiring diagram on the screen, it's actually quite easy. I probably could have done it a little bit nicer, but at that point I wanted to finish this thing already. After the wiring harness was complete, I plugged everything in and I found out that it didn't work. After a little bit of debugging, I found out that I hooked up the 5V wire to the wrong pin on the ESP32. Luckily I didn't fry it doing that. After I got that resolved, it worked like a charm, but for whatever reason I didn't film that part. So now the only thing that was left was to close the case up and screw it together. So as you can see, the controller box is screwed to the wall and hooked up to the wall box. So now if I take the power cable for my car, plug it in, it detects the car is plugged in, now it's preparing, and it switched over to charging, and now it will slowly decrease the maximum power for the car based on the amount of solar power you're generating. It's basically a feedback loop where it checks how much power is generated and then steps up or down the power limit. If I give it a couple more seconds, exactly right. So now the power generated is 4.8 kilowatts. And the car power limit is also 4.8. It will always fluctuate a bit, especially since my home is also consuming power. And that's basically it. If everything is working, the car is lighting up properly. The other thing I implemented is the manual override. So if I flip this switch, it will say here override. It will switch to 11 kilowatts and charge the car as fast as the wall box, and especially my power company would allow me to if I didn't have solar panels. That's a bit of a weird legal thing. If I switch it back off, override goes out and it will start to scale down again. And that's basically it. Now every time I get home, I just turn this box on. I have a power switch over there where the power socket for it is, and that's that. I always only consume the power I'm generating. So this is the end of the video. I don't think there's a lot more to say. If this thing works, I probably make a version 2 where I fit everything on a single PCB, so I don't have this mess of wires inside that box. But other than that, yeah, I'm done here.